Okay, we're going to talk about the inverse functions now. Um, Now, you might remember the word inverse showing up in places like um, when you were doing operations, like if you had like 1 over 5 uh, times of 5. These are considered inverses of each other in a sense, because when you multiply them together, they undo each other. So in other words, if you took a 4 and then divided it by a 5, and then you multiplied it by a 5, you'd be back to the 4. So in a sense, division by 5 and multiplication by 5 are inverse operations. So an inverse, in a sense, undoes something that's been done. So now we want to talk about that with a function itself. So for example, if you had a function that took a number, multiplied it by 2, and then subtracted a 5 from that, how could you create a function to that would undo all that? In other words, take you back to the x. Well, you could do it if you did this. If you took a number, added a 5, and then divided that by a 2. In other words, it's the exact opposite, reverse order of these operations, uh, and they're inverses to undo it. So in other words, when you come in here, the first thing you do is multiply by 2, and then you subtract the 5. Well, for the inverse, first thing you do is add a 5 and then divide by 2. So that's this. So it's like we're going backwards. So this would be considered an inverse function to this function. Okay, g of x is an inverse function to f. Okay, so that's what the order of it does. Now, it turns out that well, the reason this is important is because we want to be able to take numbers. Remember, we start with a domain typically, and through some kind of a what we would call the function itself, some way some way of corresponding, assigning values over here to values over here. Okay, that's your formula that does that. We want to be able to take the points over here that were in the range and find out where did they come from. We want a formula to do that, to go backwards from here back to this way. And that inverse is what does that for us. Under certain circumstances, we may not always be able to find that inverse so that it takes us back to that unique point that it came from. So there's a couple conditions we have to look out for. We'll talk about that in a minute. But so let's look at the two functions that we just worked with here. And we have a notation, by the way. If we're given a function f, then its inverse would be called f inverse, like that. So we have this special notation, which, by the way, does not mean 1 over f of x, okay? It's not that same negative exponent that we saw before. It's a special notation to represent the so-called inverse of f of x. So that's how we would read this, the inverse of f. Okay, so now let's see if, let's take an example here. What if I calculated f of, let's say 4, for this function that I have? I have a 2 times a 4 minus a 5, which is 8 minus 5 is a 3. Now, what if I wanted to use my other function here, my g, which is what I'm calling my f inverse. Okay, I'm calling it f inverse. And if I were to take now that 3 that I got here and put it into this function, I would have 3 plus a 5 over 2, which is 8 over 2, which is 4. That 4 is the same 4 over here. So that number came, I got it back by using my inverse function. I took the 3 and it took me back to the 4. Okay, so this inverse did the job. It in a sense, it undid everything that the original function did to the 4. It undid it and took me back. Okay, so it did the work. F of 4 became a 3. Then I took my inverse and I operated on that 3, and it took me back to where it came from. It came from the 4. Okay, so that's what inverses do. They give you an ability to go back where you came from when you have a function. So now that's not always going to happen. So let's look at another page here. Let's say you have a function that looks like this. Okay, and we saw plenty of these in the past, and they are parabolas basically. So let's say you started with a number over here. Well, let's make that. Let's straighten that out a little bit. Okay. Whoops, I got rid of a little too much there. Okay, so let's say it looks like that. Get rid of that. Okay, now let's say you had a point over here, and it has an x value. Okay, it generated that. Let's call it x sub 0, and let's call this y sub 0. And okay, so let's say I had a way, my function, put in the f of x0, and out comes y0. Okay. Now my inverse is supposed to take that f of y0 and take it back to the x0. But notice what happens here. If I have that y0, there's also a number over here. This could be x1. And I can see that f of x1 is also equal to y0. So now a decision has to be made. Which is it? Should it be this or should it be this? Say or x1. So in order to prevent that from happening, getting two answers like this, we say that we can only find inverses for certain types of functions. And this type here won't work. It will not work for us. We prefer only to work with what are called one-to-one functions. So a one-to-one function looks like this. One-to-one. It's monotonic, which means it's either always increase or non-decreasing, we'll say non-decreasing, or non-increasing. And it looks like this. That's an example, or like that. Okay, it does that. It never goes two directions. It always either goes upward or it goes downward. And it's a function, if it has that property, it's called one-to-one. Only one-to-one functions have inverses. Okay, only one-to-one functions have inverses. That's how we say it. Okay, so you can look at a graph, sample graph, and tell that it's not one-to-one by drawing a line across like that. That's called the horizontal line test. This is not one-to-one. Okay, here's an example here that is one-to-one, because no matter what you do, when you draw that vertical line, it only crosses in one place. This is one-to-one. So whatever this function is, it'll have an inverse. Okay, has an inverse. Has no inverse. So it has to be one-to-one to have an inverse, and we can use our horizontal line test to check for that. All right, now, so you wouldn't want to try to find something that's not there. You'd be wasting your time. So this will tell you whether or not it's there. Now, what we're going to do next is look at how to actually find the inverses. Okay, so because we don't want to have to backtrack, we're going to have some examples that are kind of messy. So let's say we have this function is 3x minus 5. And we want to find its inverse. Well, first of all, does it have an inverse? Well, yes, because we know that's a straight line. It approximately does something like that, down at -5, and has a slope of 3. So it will pass the vertical line test. Yes, it's one-to-one. It has an inverse. Okay, so the procedure to find that inverse is like this. Procedure to find inverse. First of all, you're going to switch x and y, because what this does is it reverses the roles of x and y so that the operations are acting in reverse in a sense. Switch x and y. So let's see what that does for us. We'll have switch x and y. Now, by the way, that is y. Y is f of x. So we have this. And then you're going to switch x and y. It's going to become this. Now, technically, this is the inverse. That is the inverse. That's the relationship. All you have to do is switch the x with the y. And that's enough to give you the actual inverse. But that doesn't always help us when we're working. So our second step would be to solve for y, because we prefer to have it in that form. Y is a function of x. Even if it's an inverse function, we still like to have that form. So this would be x plus y, 5 is 3y, and y would be x plus 5 over the 3. That's what we would call, that would be your last step. Label that f inverse. Not to be confused with the first y that we had up there. Okay, so this is the procedure. Switch x and y, that's important. That creates this thing. And that is the inverse equation right there. That's what does all the mechanics of switching x and y, or switching the. So just to recap what we just did there. What we said, we're trying to find the, let's see here. You're trying to find a way to, in this case, we have points on this line here. Let's say you got this point and this point, for example, and that point is 5/3, 0. Okay, and this point down here is 0, -5. And the whole purpose of the inverse was to create something that took the y values and put them back to the x's. So if I want that to happen, if I want a function that has 0, 5/3 as one of the points and -5, 0 as one of the points, in essence, I'm switching the x's with the y's. In other words, this first point here became this. So if those are the conditions that I'm forcing the ordered pairs to placing upon the ordered pairs, then essentially I'm switching the x's with the y's in my ordered pairs, and that's why I did this. Okay, switch the x and y achieves that. It creates that new function. This will be a new function now, such that all the ordered pairs have the x's and y's reversed, and that is this. The process of solving it for y now is here. It's required here if you want to have a nice, tidy function that's solved for y in terms of x. And you can see when you take those steps, the actual unraveling of the function. We do that. And when we talked about the order in which things are done. In the first function, the order is 3 times x and then minus a 5. In our inverse here, notice the first thing we did was we added a 5 in order to get what we wanted, and then we divided by 3, and that's this. So it's all encompassed in here. It undoes what the original function did. It takes you back to the number that you started with. So that is how we find our function. Now, let's take another example. Okay, let's find the inverse. This one. Okay. Now we will assume that it's 1 to 1. We're not going to check. We're not going to force ourselves to check that, but we'll assume that it's 1 to 1. So if you don't know for sure, then you shouldn't assume. But I'm going to tell you this one's 1 to 1. So that means that it will have an inverse. All right. So first step, if you want to, you can write that as y. Might make it easier. Second step, switch them out. That's what actually creates the inverse right there. Switching the x and y. It places all the it reverses the x coordinates with the y coordinates and creates a function for which that happens. And now we want to solve this for that function, for that y. Okay, so let's see, I'm going to multiply by that. Then let's see, I'll have to 2yx plus x is 6, and I can subtract that x, and then I'll divide by 2x, 2x, so I have 6 minus x over 2x. Okay, so that one was a little more complicated when you think about what had to be done to make it happen, because of this fraction here. When you look at what was done to x initially, the first thing you do to x is you multiply by 2. Then you add a 1. Then you find a reciprocal of that. Okay. Or we'll say, how can we say that? Or we could say divide into 6. Okay, divide into 6. So it gets a little complicated to try to go backwards with those operations because it's kind of messy. The algebra takes it through us, through there. We get to what we need with the algebra, but when you do it this way, it's much more. So as I was saying over here, let me switch back to red. Okay, so that's what this function did right here. It takes a number and in order of operations, if we had an x in here, we would multiply by 2. So that tells us 2 multiply. Second, you would add a 1. Add 1. Third, you would take that result and find the reciprocal of it, because notice it's in the denominator here. Okay, so I would make a note to take the reciprocal of that, so that whatever that is, 1 over that number, and then multiply by a 6. Okay, since it's in the denominator. So to reverse that, you would, for the inverse, you would, instead of multiplying by 6, you would divide by 6. So you take an x. So here, we take an x, and we do this to it. Here we take an x, and we do the opposite of this. So opposite of reciprocal is reciprocal. Okay, that's an e there, reciprocal. And then the third step is opposite of adding 1, so you would subtract 1. The fourth step would be opposite of multiplying 2, you would divide by 2. Just divide by 2. Okay, now, if we actually followed that, let's get rid of that there. That's, I'll take that one step at a time. I'll show you. If you actually followed that order, take a number, divide by 6. Find the reciprocal. 6 over x. Subtract the 1. Divide by 2. So that's the same thing as multiplying by half, right? Divided by 2. Now, is that the same thing as this right here? Same thing. Well, let's check it. That this becomes inside here. Notice there's a single fraction. Maybe we can get that to half in here. 1/2. So 6 minus x over x like that, which is a 6 minus x over 2x. Notice that's the same thing we got over here. Now, I would say that what I did here was more difficult to follow this reasoning. It's not practical. It's not a practical way to get the answer. The practical way is just come in over here and literally switch x with y, which is what I did here. Okay, that achieves all of this. In addition to what I did here, it achieves all of this right in here. And then the actual mechanics of it are gotten by solving for y. So you actually go through these mechanics here to get to that expression. Okay, now let's take another one of these. Let's try it. Let's say g of x. Oh, by the way, that one. Let's see, what did I say? Over here, there was one more step when we're done here, and we would say f inverse equals that 6 minus x over 2x. Okay, we don't want it in that form. All right, so let's try this next one. Here's an example, g of x equals, let's say 3 minus 2x, period, that's it. Okay, let's find the inverse. So first step, we'd have switching x and y. So remember, this is y, and I'll switch it now. Okay. Third step, let's solve. Solve for y. Now, so you want that to be a function of x. So first thing I do is, well, I could take away that 3, and then I'll divide by -2. So I'd have this. Okay, and I'm gonna turn it around like this. And I don't like that negative in the denominator either, so I'll just write it this way, 3 minus x over 2, like that. And then finally you can write the inverse notation. 3 minus x over 2, that's your inverse. Now what I want you to see is these two lines together. Okay, so the first one is this one. We can see that slope is -2, y-intercept 3. So you're up here at 1, 2, 3. And slope is -2, so it comes down. Here's a couple points. Okay. This point is 0, 3. And this point here was, that was 1, 1, right? Yeah. Okay, now, this other function is this one. This has a y-intercept 3/2 and a slope -1/2. Okay, So at 3/2, which is here, let's see, I'll do this one in blue. 3/2 is here, and the slope -1/2 means I'm going to come down. If I go down 1 unit, I'll go to the right 1 unit or 2 units. So if I go down 1, I'll go down 2. So I'll be actually over here. Let me just make sure that's okay. I'm going to put this back in. 0, 3/2. Okay. And if we come down 1/2 and over 1, I'm right here. So that point is 1, 1. It's the same point. And then connect the dots. So, and extend out like that. Okay. Now something you notice, mine's a little off there, but it comes in more like that, up like that. So I don't want to be trying to be neat on this, but that's good. Okay. Something you notice about these lines is that they're always symmetric to this line here. In other words, you could imagine flipping this line this way over that line, you would get the red line if you reversed everything. This point comes over here, switches with this point, same thing here. This one is switched with this one. And they're the reflections over that line, y equals x. And you also notice that independently I came up with ordered pairs that were, well, this one here anyway, you saw it was exactly the opposite of this one. Switch the x and y. This one over here, I didn't get that ordered pair. I didn't find it, but it looks like it's about at 3 to me over there, which would make sense because this one is 0, 3 up here. So you can check it over here. What happens when y, well, when y is equal to 0? What is x? This, well, it's 0 equals 3 minus x. X is 3. That is that same point. So you see that nice relationship with the reflection over that line. In general, if you, for instance, if you had one, oops, extra button in there. Whoa. Okay. Let's take that off there. And just kind of draw a nice line in here like this. Let's say you had a line coming in like this. Then the inverse would be over this line here. And it would come in like this. That. I'm not doing justice to that, but reversed over this line, reflection over it. Okay. Anyway, so that's something else about these when you talk about the, it's not so obvious with these lines that we've been working with, but with other functions, since you switch the x and y's, something else that occurs when you have inverses. So in other words, if this is f of x, which has a given domain and range, then f inverse, its domain would become the range of f, and its range would become the domain of f. So they're switched. Okay, they're switched with each other. Now that's, when you have all real numbers, you can't really tell that that happened. But it is happening with some of these other, with all of these other inverses. Okay, so that's probably enough of the inverse.